Today we're going to learn lesson 6 of unit 2, trigonometric functions. We're going to have a look at 6 trigonometric functions, including sine, cosine, tangent, cosecant, secant, and cotangent functions. And after today's lesson, you should be able to sketch the graphs of these functions and understand and interpret the main properties of these functions and solve real-world problems involving trigonometric functions. Okay, so first of all, let's have a look at the sine function. All right, if you plot the sine using technology or using a pencil and paper, you will have a look at a sine function will have this shape, right? It will start from the original point and go all the way up to its maximum point 1. And then go back to 0 when x is pi. And then when x is 3/2 pi, the function will arrive at its lowest point, which is -1. And then go back to 0 when x is 2 pi. And then this is one cycle of this function. And after that or before that, the function just repeats this behavior in other circles. So this is one of the properties of the sine function. It is a periodic function. It just repeats itself in this cycle over and over again. Okay, and we can also verify the behavior of the sine function using a unit circle here. Suppose this is a unit circle here with a radius of 1, and point P is on the terminal side of an angle theta. So when theta is 0, apparently sine 0 is 0, right? And when 0 goes up from 0, when theta goes up from 0 to 1/2 pi, as you can see, the y coordinate is sine theta, right? Because according to the definition of sine theta is just y over r. R is 1, so the y coordinate here is sine theta. So as theta goes from 0 to 1/2 pi, the y coordinate is going up from 0 to 1, right? So this corresponds to the behavior of this section. As theta goes from 0 to 1/2 pi, sine theta goes from 0 to maximum value of 1, right? It is increasing in this section. And after that, theta goes from 1/2 pi to pi, right? And in this process, the y coordinate decreases from the maximum value of 1 to 0, right? So this corresponds to the section here. And after that, theta goes from pi to 3/2 pi, right? So as you can see here, sine theta goes from 0 to -1, right? So that corresponds to this section here. And last, when theta goes from 3/2 pi to 2 pi, the y coordinate sine theta goes from -1 to back to 0, right? So it is increasing from -1 to 0, right? So for each of the quarter cycle, the function has a behavior like this, right? You can always verify its behavior with the help of unit circle. Okay, so let's make a summary of the main properties of the sine function. F theta equals sine theta. But first of all, the domain of this function is -infinity to +infinity. That means there is no constraints to the domain. The range is -1 to 1 inclusive, right? Of course, maximum value is 1 and minimum value is -1. And this function is actually oscillate between -1 and 1. And we call this behavior with a amplitude of 1, right? The amplitude is defined as the maximum distance between the original point to the top, to the maximum value, or to the minimum value, right? So this distance here is called amplitude. And because sine theta plus 2 pi equals sine theta is a periodic function, and period is 2 pi. Okay, so in this course, when we say a periodic function with a period, the period is the minimum value possible period in this course, okay? Which is also called the fundamental period. Okay, y-intercept. Of course, when x is 0, y is 0. X-intercepts, that means all the point where the y-coordinate is 0, right? So there are infinite number of x-intercepts. And we can use an expression to express the x-intercept, which is k pi 0. That means when x is k pi, y is 0. K belongs to an integer. For example, the x-intercept can be 0, 0, pi 0, 2 pi 0, 3 pi 0, etc. Right? So why it is k pi 0? Because k pi is just an angle with terminal side on the x-axis. When the terminal side is on the x-axis, sine y is 0, right? Sine y is 0. Sine theta is 0. That means the y-coordinate is 0. So that is the x-intercept of this function. Next, let's look at the parity of this function. Because sine minus theta equals sine theta, so sine theta is an odd function. It has a point symmetry about the origin point, right? Okay, next, the increasing intervals. So first, let's have a look at one cycle. If we look at this cycle here, this is also a cycle, right? Because this cycle just repeats itself in other intervals, right? So let's have a look at this cycle first. Apparently, in this cycle, the increasing behavior is minus half pi to half pi, right? That means this side. And then, because it is a periodic function, we can just plus 2k pi to the lower limit, and at the same time plus 2k pi to the upper limit. So all these intervals here are increasing intervals. Do you understand? So for example, if k equals 1, then this interval will come here, right? This interval is also an increasing interval. And if k equals 2, this interval will be here, right? And if k is minus 1, this interval will be here. So all of these intervals are increasing intervals. Do you understand? Okay, all the decreasing intervals. Of course, let's consider one cycle first. Again, let's consider this cycle. So one of the decreasing intervals is half pi to 3 pi over 2, right? Inclusive. So that means this section is a decreasing interval, right? As x decreases, y also, as x increases, y decreases. And if you want to express all the decreasing intervals, we can just plus 2k pi, because 2 pi is the period. So this means all the decreasing intervals can be expressed as this, k belongs to an integer set. You understand? This is a main feature of the sine function. Any questions? No? Okay, so next let's have a look at cosine function. Again, if you plot it using a pencil and paper or using technology, you can have a look, you can have a shape of the cosine function like this. It starts from 0, 1. When x is 0, the function is 1, right? And come all the way down and cross half pi 0, and then go all the way down to pi minus 1. And then come back to 3 pi over 2, 0, and then to the maximum point 2 pi 1 again, right? So again, this is very similar to the sine function, except there might be a horizontal shift, right? Again, this is also a periodic function. For example, it just repeats itself over and over again. This is one of the cycle, right? And you can see that there is another cycle here, and there's another cycle here. It just repeats itself cycle by cycle, right? And again, we can also verify these behavior with the help of the unit circle here. For example, if theta goes from 0 to half pi, that corresponds to a section here, right? The function value comes from maximum value 1 to 0, right? Okay, so let's make a summary of the main behavior of this function. First of all, domain is all the set of R, right? So theta can be any real number. Range is -1 to 1 inclusive. Maximum value is 1 and minimum value is -1. And again, similar to sine function, the cosine function also oscillates between -1 and 1, and the amplitude is 1. Again, because cosine theta plus 2 pi is cosine theta, so cosine theta is also a periodic function. Period is 2 pi. Again, when we say period in this course, we mean the fundamental period, which is the possible least period, which is a possible least positive period. Okay, y-intercept is 0, 1. That means when x is 0, y is 1, and x-intercepts can be expressed as half pi plus k pi 0. Why? Because half pi plus k pi is just all angles with the terminal side on the y-axis, right? So when the terminal side on the y-axis, cosine theta must be 0. That means that's the x-intercepts, right? Okay, next let's consider the parity, because cosine minus theta equals cosine theta for all theta. So cosine theta is an even function. It has a line symmetry about the y-axis, right? Okay, so all the increasing intervals is minus pi plus 2k pi to 2k pi. And all the decreasing intervals are 2k pi to pi plus 2k pi, where k belongs to an integer set. This is similar to the sine function. It has infinite increasing intervals and infinite number of decreasing intervals. Understand? Any questions? No? All right, so I just want to mention that because we have this equivalent expression, right? Sine theta plus half pi equals cosine theta. That means the sine theta and cosine theta are actually interchangeable by a horizontal translation, right? For example, if we look at the first graph, the green line here is sine theta. And if we plot sine theta plus half pi, this dotted line is sine theta plus half pi, right? And this dotted line here is actually the same with the cosine here, because these two functions are actually the same, right? We have sine theta plus half pi equals sine cosine theta. Do you understand? That means theta and cosine theta are interchangeable by a horizontal translation. We're going to talk about the transformations of the trigonometric functions in next lesson. So we'll see more details next lesson, okay? All right, so now let's consider a practice. State the domain and range of each of the following functions, okay? I'll give you 5 minutes to think about this question. All right, have you finished? Okay, so first let's have a look at the domain. Question A, domain is apparently minus infinity to positive infinity, or the whole set of R, right? And range, because sine something is between -1 and +1, right? So sine x plus 2 plus 4 is just 3 to 5, right? Okay, so the range is 3 to 5. Okay, second one, again, the domain is just the whole real number set. And the range is, so note here, cosine angle is between -1 and 1, right? And if we -5 to both sides, that gives us -6 to -4, right? Okay, so the range is just -6 to -4. Okay, any questions? No? All right, so let's have a look at the next function. Next function is tangent function. So again, if you plot this function using a technology or pencil and paper, you will have a pattern like this, right? So it looked like tangent theta is another periodic function, right? So, but this time, note that the period is pi, not 2 pi. So note here, this is one of cycle, right? And as you can see here, this is half pi, and when this point comes here, this cycle just the same with the previous one. So the cycle is pi, not 2 pi, right? Okay, and also you can verify this behavior with the help of the unit circle. For example, if we consider theta from 0 and approaching half pi, that means from here to here, right? When theta is 0, tangent theta is 0, right? As theta increases to half pi, tangent theta also increases from 0 to positive infinity, right? So note here there are vertical asymptotes for tangent theta. Tangent theta cannot be at this point, right? At this point, tangent theta just not defined. Okay, so let's have a look at the main properties of tangent function. Okay, so please remember this pattern for tangent theta. First of all, domain is theta belongs to R, but theta cannot be half pi plus k pi. Why? Because when half pi plus k pi, when theta equals half pi plus k pi, that means theta must lie on the y-axis, right? If it lies on the y-axis, that means the x coordinate is 0. So according to the definition, when the x coordinate is 0, that means the denominator is 0, right? When the denominator is 0, that function is not defined there, right? Okay, and then let's consider the range. Range, according to the graph, is of course negative infinity to positive infinity. That means the whole set of R, right? Okay, next let's consider the parity. Because we have already know that tangent theta plus pi. Next let's consider is whether this function is a periodic function. Because we know that tangent theta plus pi equals tangent theta. That means tangent theta is a periodic function with a period pi, right? So it just repeats itself over and over again. So the y-intercept, that means when x is 0, y is 0. So the y-intercept is 0, 0. X-intercepts are these points, right? So apparently, when the terminal side lies on the x-axis, that means the x-intercepts are there, right? So when the angle's terminal side lies on the x-axis, that angle can be expressed as k pi, right? If k is an odd number, terminal side will be here. And if k is an even number, the terminal side will be here. Sorry, if k is an even number, the terminal side will be on the positive side of x-axis, right? And if k is an odd number, the terminal side will be on the other side, right? So k pi means all the angle with terminal side on the x-axis, which means when the y coordinate is 0. So the x-intercepts can be expressed as k pi 0. K belongs to the integer set. Okay, next, because tangent minus theta equals minus tangent theta. So tangent theta is an odd function. That means it has a point symmetry against the origin point, right? Okay, again, we can analyze that the increasing intervals is from minus half pi plus k pi to positive half pi plus k pi. For example, this is one of the increasing intervals, right? And because it is a periodic function, for the next cycle is also a periodic function, right? And note that we have vertical asymptote, which can be expressed as half pi plus k pi. Again, the reason we use half pi plus k pi, that means when theta is lying on the y-axis, the function is just not defined there. So that's the vertical asymptotes of tangent theta, right? Okay, so please have a look at this pattern again. Do write them down and draw them down onto your notebook. It is very helpful to solve problems later, okay? All right, let's do a practice. State the domain and range of each of the following functions. I'll give you 3 minutes to think about this question. All right, have you finished? Okay, for the domain, let's consider the first question. The domain is, according to the analysis in this slide, we know that x minus a quarter pi cannot be half pi plus k pi, where k is any integer number, right? So that means x cannot be 3/4 pi plus k pi, right? This is our domain. There is a constraint for the x variable here. Okay, for the range, we have already know that the range of tangent theta is minus infinity to positive infinity, right? And then if you add a 3 to tangent theta again, of course, the range is also negative infinity to positive infinity, right? Okay, so next question. Okay, again, let's consider the domain first. We know that x plus half pi cannot be half pi plus k pi, right? And k belongs to the integer set. Therefore, x cannot be k pi, where k belongs to an integer set. This is our domain. And as to the range, we know that tangent theta has a range of negative infinity to positive infinity. And then if you subtract it using a 6, the range is also negative infinity to positive infinity. That means the whole set of real numbers, right? Any questions? No? Okay, so you can also check the solutions on this slides after the class, okay? All right, so next, let's have a look at the cosecant function. So note that the cosecant is just the reciprocal of sine, right? So in this graph, first we draw the sketch of the sine function, and using the behavior of the sine function to sketch the graph of cosecant function. So as you can see here, because sine function is a periodic function, that means cosecant function must also be a periodic function, right? So if we consider their behavior on this cycle here, we can just study its behavior on one of the cycles, right? Because periodic function just repeats this cycle over and over again. So let's consider the behavior on this cycle first. In this cycle, as you can see here, because cosecant x is just the reciprocal of sine x. So when x becomes, when x goes from 0 to half pi, sine x is increasing from 0 to 1. And its reciprocal should decrease from positive infinity to 1, right? And when x goes half pi to pi, sine x goes from maximum value 1 to 0. And at the same time, its reciprocal cosecant x goes from 1 to positive infinity, right? So between 0 and pi, cosecant x will have a shape like this, right? And same thing will happen when x goes from pi to 2 pi, right? When x goes pi to 2 pi, cosecant x will go from negative infinity to 1, and then from 1 to negative infinity, right? Okay, so let's make a summary of the main properties of the cosecant function. First of all, the domain. Domain is now not the whole real number set, right? X cannot be here, 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 and here, because at this point, the denominator will be 0, where the function is not defined. So that expression is X cannot be K pi, right? K pi is all the angles where the terminal side is on the X axis, right? So this is our domain. Range is simply minus negative infinity to minus 1, and then 1 to positive infinity, right? If you can have a look at the graph, we know that the cosecant cannot be any values in between minus 1 to positive 1, right? Okay, so again, it is a periodic function with a period of 2 pi. And it also is an odd function because it is the reciprocal of sine x. And so that means the parity should be the same with sine x, right? The y-intercept does not exist, and there is no x-intercepts as well. Vertical symptoms are these lines, which can be expressed as half x equals k pi, right? And increasing intervals are half pi plus 2k pi to pi plus 2k pi. That means all the intervals here and here. Or okay, all the increasing intervals can be expressed here and here, right? Or here, 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 and here. All these intervals can be expressed using these two expressions, right? And decreasing intervals can be expressed as minus half pi plus 2k pi to 2k pi, and then 2k pi to minus 2 to half pi plus 2k pi. Understand? There are increasing intervals and decreasing intervals. Please have a look at this pattern, and I hope you can draw this sketch by yourself on your notebook, okay? I'll give you 2 minutes to draw a sketch of the cosecant x on your notebook. All right, so let's have a look at the next function, which is secant function. Again, which is similar to the cosecant function, is just a reciprocal of sine function. The secant function is just the reciprocal of cosine function, right? So we can analyze its behavior with the help of cosine function. So first of all, in this graph, we draw the cosine function in the dashed line like this. And then with the help of cosine x, we can analyze the behavior of secant x, right? So for example, we can consider the cycle from 0 to 2 pi again, okay? This is one of the cycles of some cosine x. So when x from 0 to half pi, cosine x is decreasing from 1 to 0, right? At the same time, the secant x, because it is just the reciprocal of cosine x, is increasing from 1 to positive infinity, right? And for another example, if we consider next a quarter period, when x goes from half pi to pi, cosine x goes from 0 to -1, right? And at the same time, secant x goes from negative infinity to -1, right? So we can use a similar method to analyze cosecant x to analyze secant x to cosine x, just like we did by analyzing sine x to get the behavior of cosecant x in the previous slide, okay? And both of the sketch of the graph looks very similar, right? Because cosine x just a shift of sine x. So cosecant x is just a shift of secant x. So all of the graphs are connected, right? Okay, let's make a summary of the main properties of the secant function. So first of all, the domain. Domain x cannot be here, 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 right? Which can be expressed as x belongs to real number set, but x cannot be half pi plus k pi. All these circle numbers here can be expressed as half pi plus k pi, because half pi plus k pi is just all the angles whose terminal side is on the y-axis, right? When the terminal side of the angle is on the y-axis, the x is 0. That makes the denominator be 0. So that means the function cannot be defined there, right? Okay, again, the range is negative infinity to -1, union with 1 to positive infinity. So there is no values in between -1 and 1, right? Which is similar to cosecant x. All right, next period. This is also a periodic function with period of 2 pi. Again, next, the parity. It is obviously a even function, right? Because it is the reciprocal of cosine. Cosine is an even function, so secant x is also an even function, with y-intercept is 0, 1, because when x is 0, 1 is simply 1. And x-intercept does not exist. Vertical symptoms are x equals half pi plus k pi, right? Okay, increasing intervals are these. So this is an increasing interval. This is another increasing interval, which can be expressed as 2k pi to half pi plus 2k pi, and half pi plus 2k pi to pi plus 2k pi. The reason why we add plus 2k pi is because it is a periodic function, right? So once you have found one of the increasing intervals, you can simply put positive 2k pi after the lower limit and the upper limit to expand it to other cycles. Understand? So similarly, decreasing intervals. So one of the decreasing intervals, for example, here is a decreasing interval, and here is another decreasing interval, which can be expressed as minus pi plus 2k pi to minus half pi plus 2k pi, and minus half pi plus 2k pi to 2k pi. Understand? Do you have any questions? Okay, again, I'll give you 2 minutes to sketch the graph of secant function on your notebook. Do try it by yourself, okay? And get yourself familiar with the pattern of the graph of secant x. Okay, have you finished? Let's do a practice, okay? When the sun is directly overhead, its rays pass through the atmosphere as shown in the graph here. Call this one unit of atmosphere. When the sun is not overhead, but is inclined at an angle x to the surface of Earth, its rays pass through more air before they reach sea level. Call this y units of y-sphere. The value of y affects the temperature at the surface of Earth. Use the diagram to determine an expression for y in terms of angle x. Graph y equals fx on the interval 0 to half pi inclusive. Describe what happens to the value of y as x approaches 0. Okay, I'll give you 3 minutes to think about this practice by yourself, okay? All right, let's have a look at the solutions. First of all, use diagram to determine expression for y in terms of angle x. So if we consider this triangle here, apparently this is angle x, right? Because this line is parallel to this line. We know that this angle is x here. Okay, this is angle x. So in this right triangle, we know that sine x equals 1 over y, right? And this gives us y actually equals 1 over sine x, which is cosecant x, right? Okay, next let's sketch the graph of cosecant x on the interval 0 to half pi. So in order to draw the sketch of cosecant x, usually we'll consider the sine x first. So for the sine x, it has a pattern like this, right? And with the help of sine x, we know that cosecant x has a pattern like this, right? And note here the corresponding x coordinates 0, half pi, pi, 3 pi over 2. Sorry, made a mistake here. This is 3 pi over 2, and this is 2 pi, right? And here is another half pi, which is 5 pi over 2, and etc., right? So we only need to sketch the graph on 0 to half pi. So this graph should look like this, right? We only keep this branch here. So if you want to separate the graph, you can then draw another graph here. This function should look like this one, right? And this is half pi, and this is 0, right? And the coordinates of this point is half pi, 1. Okay, so this is solution of the second question. C, describe what happens to the value of y as x approaches 0. So when x approaches 0, as you can see from the graph, y should approach the positive infinity, right? So we can make the conclusion here. When x approaches 0, y approaches positive infinity. Understand? Okay, you can also check the complete solution on these slides after the class, okay? All right, so let's have a look at the next function, which is the last one in this class, the cotangent function. So remember that cotangent function is defined as any, if you have any point on the unit circle and unit circle intersects with the terminal side here, the cotangent x is defined as x over y, right? Which is cosine theta over sine theta in this graph, right? Okay, so if you sketch cosine theta using technology or paper and pencil, you will have a pattern like this, which looks like the tangent theta in the mirror, right? Remember that tangent theta has a pattern like this, right? And cotangent theta has a pattern like this. You understand? But this time, we know that when x is 0, the function is not defined, right? Whereas in tangent theta, when x is 0, y is also 0. So pay attention to the difference. So again, let's make a summary about the main properties of the cotangent function, f theta equals cotangent theta. First of all, the domain. Domain cannot be the whole real number set. The domain is a real number set except theta equals k pi. K equals any integer value. So k pi is actually all the angles with terminal side on the x-axis, right? And we know that if the angle's terminal side is on the x-axis, the cotangent theta is not defined, right? Because in that case, the y coordinate is simply 0. And in cotangent theta, the y coordinate is in the position of denominator. The denominator cannot be 0. And range is negative infinity to positive infinity, as shown in this graph. Also, it is a periodic function with period of pi, right? Because it is just a reciprocal of tangent theta. Tangent theta has a period of pi. Of course, cotangent theta also has a period of pi, right? There is no y-intercept. That means when x is 0, the y value is not defined. And x-intercepts are these points here. All of these points can be expressed as half pi plus k pi, which means any angle with the terminal side on the y-axis, right? Again, this function is an odd function, which is the same with tangent theta, because we have cotangent minus theta equals minus cotangent theta. We have already learned about this, right? Decreasing intervals can be expressed as k pi to pi plus k pi. For example, if we consider a cycle here, in this cycle, this function is a decreasing function, right? And because it is a periodic function, so we can express all of the decreasing intervals using k pi plus k pi, or k pi to pi plus k pi. And k is any integer number. Okay, last, vertical asymptotes can be expressed as theta equals k pi. That means all the asymptotes here. Okay, any questions? All right, please spend some time and try sketch the graph of cotangent theta onto your notebook and get yourself familiar with the pattern of this function, okay? It will be very helpful when we solve problems involving cotangent function. Okay, I'll give you 3 minutes to try to sketch this function onto your notebook. All right, have you finished? All right, let's have a look at a practice. Show that the graph of y equals cotangent x can be obtained by reflecting the graph of y equals tangent theta in the y-axis and then horizontally translating it to the right by half pi units. Okay, I'll give you 5 minutes to think about this question. All right, so let's have a look at solutions. So note that cosine x can be rewritten as tangent half pi minus x, right? This is according to the cofunction identity, which is tangent minus x minus half pi, right? And we know that for this function, this parameter here corresponds to a reflection in the y-axis, right? And this parameter here means a horizontal translation by a unit of half pi to the right. Understand? So let's have a look at how do we achieve this in this graph. So suppose the y-axis is here, x-axis is here. So the original tangent x is the red curve, right? And we know that by reflecting the y-axis and then translate horizontally to the right by half pi units, this function will become here, which is exactly the graph of the cotangent function, right? So in this way, we have shown that the graph of tangent x and graph of y equals cotangent x is also interchangeable by a reflection in the y-axis as well as a horizontal translation, right? Okay, so I hope we can understand all of these 6 trigonometric functions here we have learned for today. And let's make a summary of today's learning goals. So now you should be able to sketch the graphs of the sine, cosine, tangent, cosecant, secant, and cotangent functions, and understand and interpret the main properties of the sine, cosine, tangent, cosecant, secant, and cotangent functions, and use these functions to solve real-world problems. Okay, so I hope you can try to sketch the graphs of all these functions on your notebook after the class. All right, so that's all for today. The rest of the time, you can start doing today's homework. Okay,